Hello everyone, welcome back to the Math UMS class, week number 26. In this previous lesson, we have focused on how to calculate the volumes of some solids with uniform cross-section. The solids with uniform cross-section are the solids that when cut by a parallel slice, the slices that are parallel to a face of that. So the cutting surface will be equal, independent on the position of the cut. If we cut it from this, we will have the same cutting surface as when we cut at that position. But today, we will focus on the solids that are not of uniform cross-section. The cross-section will be different. Okay, let's begin the lesson. Hello everyone. The first section about pyramids and cones. Now let's have a look at the pyramid. We have the base. The base is a rectangle. In this case, we will consider a rectangular pyramid. The height, the apex that is the point that is outside of the base, and from the apex we connect it to the points on the base. And each of the side face is called the lateral face. Lateral means side, the lateral face. Okay, you can see that in the pyramid, if you cut the pyramid by a cut that is parallel to the base, so the cut of different positions will have different size. It has the same shape. They are all rectangular, but they have different size. It is smaller at the top and it is bigger closer to the bottom. So this is not a solid of uniform cross-section. Now we come to the volume formula for the pyramid. The volume is 1/3 times base times height. So you can see that instead of taking only the base and the height multiplied together, we will then multiply it by 1/3. For example, if we have this pyramid, the base is a rectangle of the length 8 cm and the width 4 cm. The height of the pyramid is 6 cm. And now applying the formula to the pyramid, the volume equals 1/3 times base times height, and then the base area is going to be 4 times 8 equals 32 square centimeters. Now the volume is 1/3 times 32 times 6 equals 64 cubic centimeters. Okay, remember this formula already? I think you can remember it already because it is very simple. Example number 1. Find the volume of the pyramid below. In this pyramid, we are not given the height of the pyramid, so we need to work it out ourselves. We are given the edge of the pyramid. SA is equal to 10 centimeters. So we need to somehow find the length of the segment ASO, which is the height of the pyramid SO. Okay, I think you should pause this video for a while and think of this problem yourself before checking the answer. Okay, have you got the answer? Let's check it. So in order to find SO, we need to find AO first, so that we can apply the Pythagoras theorem. And the diagonal of the base, which is AC, is equal to the square root of 6 squared plus 6 squared, and it is equal to the square root of 72 centimeters. It implies that OA is equal to half of it, square root of 72 divided by 2 centimeters. And applying the Pythagoras theorem, SO is equal to the square root of 10 squared minus the square root of 72 over 2 all squared, and the answer should be the square root of 82 centimeters. So now we have the height of the pyramid, the square root of 82 centimeters. Applying the formula for the pyramid, the volume, we have the base area. The base area is 6 times 6 equals 36 square centimeters. So the volume of the pyramid is 1 over 3 times the square root of 82 times 36, and that is equal to 12 the square root of 22, and approximately 108.7 cubic centimeters. I hope that we all have the same answer. Okay, now you can see how the formula works. I'm moving on to the cone. In the cone, we have the curved surface of the cone, we have the base, the radius, the slant height, and the apex. We have already learned this in some lesson, like 2 or 1 month ago when we learned about the surface area. Alright. Now let's try to calculate the volume. Similar to the volume of a pyramid, the volume of a cone is 1 over 3 times base times height. The base area is the pi r squared, which is pi h squared in this case, and it is equal to 64 pi square centimeters. The base area is 64 pi square centimeters. The volume of it is equal to 1 over 3 times 64 times 16 equals 1024 divided by 3 pi cubic centimeters. I think the formula is very easy because it is similar to the formula for the pyramid. Now example number 2. Calculate the volume of the cone below. Again, in order to find the volume, we need to find the height SO of the cone. We can apply the Pythagoras theorem because we all know that SOA is a right triangle with O is equal to 90 degrees, right? SO is equal to the square root of AS squared minus AO squared and equals to the square root of 10 squared minus 6 squared equals 8 centimeters. So SO is 8 centimeters. Now applying the formula, base area is pi 6 squared equals 36 pi centimeters. 36 square centimeters, sorry for my mistake. The volume of the cone is 1 over 3 times 8 times 36 pi equals 96 pi cubic centimeters. Okay. 96 pi square centimeters. I think this problem is still very straightforward. It is not too difficult to know how to find the length of SO. Moving on to the next section, we are discovering the formula for the volume of a sphere. That is straightforward also. Here we have a sphere. In the sphere, there is only one measurement, which is the radius of the sphere. That is the only parameter that affects the size, and so the volume, the surface area, anything of the sphere. We have the center, the radius, and the great circle. Here we have a sphere of radius 6 centimeters. Now we need to find the volume of it. So here is the formula for the volume of the sphere. It is equal to 4 over 3 pi r cubed. 4 over 3 pi r cubed. And in this sphere, whose radius is 6 centimeters, the volume is gonna be 4 over 3 pi 6 cubed equals to 288 pi cubic centimeters. Okay, I think it is still very easy to remember. Maybe the 4 over 3 is quite hard to remember, but it has only one parameter, r. Okay, example number 3. Calculate the volume of the sphere below. And I think this problem can't cause you any trouble, right? You can solve this right away, I believe. In this problem, we are given the diameter of the sphere. So very naturally, we will try to find the radius of it, and it is very easy to find. All you need to do is to take half of the diameter. So the radius of the sphere is 20 divided by 2 equals 10 centimeters. So now we know the radius. The volume is 4 over 3 pi 10 squared, and it is equal to 400 over 3 pi and approximately 233.3 cubic centimeters. Okay, I think it is not difficult, right? Now comes the practice section with more challenging and more interesting problem, I believe. Problem number 1. Calculate the volume of the solid below. Here we have half of a sphere, which is called a hemisphere, of the radius 4.2 meters. I think you guys can solve it easily. Of course, we will calculate the volume of the sphere, of the full sphere, and then take the answer by half so that we can find the volume of the hemisphere. The volume of the full sphere is 4 over 3 pi times 4.2 cubed, and it is equal to 98 times 98.784 pi cubic centimeters. And the volume of the hemisphere is 98.784 divided by 2 equals 49.392 pi cubic centimeters. I think the problem number 1 is quite easy. Now the problem number 2. Okay, now I will give you some time to think about it, or you can give yourself some time because I cannot control the time. It is a cyber lesson. So pause this video for a while and then come back to that after you have your answer. Okay, have you got it? Good, let's check it. Here we have a weird solid, but it can be broken down into two basic solids, which is a cone and a hemisphere. The solid consists of, okay, let me correct this. So embarrassing. The solid consists of a cone and a hemisphere. The base area of the cone is pi 5 squared, which is equal to 25 pi square centimeters. So first we will calculate the volume of the cone, which is 1 over 3 times 24 pi times 9 equals 75 pi cubic centimeters. And now we try to calculate the volume of the hemisphere, which is 1 over 2 times the volume of the full sphere, 4 over 3 pi 5 cubed, and it is equal to 250 pi over 3 cubic centimeters. And the volume of the solid is equal to the sum of the two volumes. 75 pi plus 250 pi over 3, which is equal to 475 over 3 pi cubic centimeters. Okay, this moving too fast, I believe. Okay, you should pause this video and think of the solution for why if you need to. Now problem number 3. Calculate the volume of the solid below. Again, we have a weird shape. It is like our pencil, and we have a 2-end pencil, and it has two ends of it, two cones, and in the middle we have a cylinder. We have some measures. We have some measures on this diagram. Okay, I think you should give yourself some time to think about yourself first. Okay, have you got it? So we need to break this solid into basic solids, which are cones and cylinder. First, we need to calculate the radius of the cone's base. You can see that the width of the cylinder is also the diameter of the base of the cone, and it is 2.8 meters. So the radius of the base of the cone is 0.9 meters. So the base area of the cone is pi times 0.9 squared, and it is equal to 0.81 pi square centimeters. The base area of the cone is pi 0.9 squared is equal to 0.81 pi square meters. So the height of each cone, you can see that the distance between the apex of this cone to the apex of the other cone is 6 meters, while the length of the cylinder is 4 meters. So the height of the height of each cone is 6 minus 4, all divided by 2. It is equal to 1 meters. The volume of each cone is 1/3 times 0.81 times 1. It is equal to 0.27 pi cubic meters. The volume of the cylinder is 4 times the base area. It is 4 times 0.81 pi equals 3.24 pi cubic meters. So the volume of the solid is the sum of the two volumes, which is equal to 0.27 pi times 2, because we have two cones, and then plus the 3.24 pi, which is equal to 3.78 cubic meters. So 3.78 cubic meters is the volume of this solid. You all have the correct answer. I hope you all do. And that is also the end of the lesson today. I hope you understand everything in this lesson, because it is quite straightforward. I think so. But if you have any question or anything that you feel unclear, don't hesitate to contact me, because I know that it is very natural to have such questions. Okay, at home I want you to review the lesson, learn by heart the formulae for volume of sphere, cone, and pyramid. And a small task for you at home, I want you to try to build a paper cone. You can go to the internet, to YouTube, to find how to build a cone using a paper, and then calculate its volume. You can measure the diameter or the height or the radius, all the things you need to calculate the volume, and then try to calculate the volume of that. Okay, and that's it for this week. See you next week then. Goodbye.